In the e-learning of chapter 1 class 7. It's all about computer system and types of software and number system and all. Computer system is a set of integrated devices that input, output, process and store data information. Computer systems are currently built around at least one digital processing device. There are 5 main hardware components in a computer system: input, processing, storage, output and communication devices. So basically in the picture you are seeing CPU, monitor, keyboard. So these are the hardware. Now later on you will know about software in detail. Which has two components, low level and high level. Low level has two components, first generation and second generation. We're talking about language, first generation language and second generation language. Then high level has three components, third generation language, fourth generation language and fifth generation language. Now we talk about low level language. Low level language means first generation. First generation means binary language. Binary language also known as machine language. Machine language is called binary language because binary language uses 0 and 1. So binary language uses only 0 and 1, and in the form of 0 and 1 data are represented. This is also called machine language. Now low level language has second component, that is second generation language. That is it. Mnemonics of assembly language. Assembly language was little easier in comparison to machine language. Assembly language was written in English and it was little easy because of the use of English, and commands were given in terms of word like INP. It was a mnemonics. It was a assembly language commands. INP, get information from some input device. So INP stands for input. Now out was making output. So the out stands for output, INP stands for input. So mnemonics were 3-letter or 4-letter commands given in assembly language. So this was little easier to remember in comparison to 0 and 1. Now this too is called low level language because it is very hard to understand. Low level means it is hard to understand, it is difficult to process. In terms of understanding and writing, it is difficult to process, whereas computer understands only machine language. Computer understands only machine language. Computer does not understand the second generation, third generation, fourth generation, fifth generation. All the languages are converted to machine language, and the machine language is directly understood by PC. Now here we talk about third generation language. So basically we talk about this particular thing. High level language means C, C++, Java. These are the high level language, and this is also called procedural language. Now this was far easier in comparison to machine language and assembly language. Very advanced kind of softwares and programs were started to be written in high level language. So high level language mean to say third generation language. Now later on we will know about fourth generation language and fifth generation language. This is all about now fourth generation. In fourth generation, this is closer to human language. A typical example of each of the use of fourth generation language is the creation of a GUI. To create a GUI in Java would be quite difficult because of the code required for each component. With any 4GL, creating an interface is a simple matter of drag and drop. This generation is used a lot with databases. So Fox Pro and Visual Basic are the great example of fourth generation language. GUI means GUI is the frame where you get menus, you get mouse pointer, you get icons, that is GUI. And with the help of third generation language, making a GUI application was a very difficult task, whereas with the help of fourth GL like Visual Basic, making a GUI application is quite easier. Now talk about fifth generation programming language. It's a neural network. Now a type of artificial intelligence that attempts to imitate the way a human brain works. A neural network works by creating connection between processing elements, the computer equivalent of neurons. Neural networks are currently used prominently in voice recognition system, image recognition system, industry, robotics, medical imaging, data mining, and aerospace applications. So when you talk about artificial intelligence, when you talk about robots, then you need fifth generation language. And a great example of fifth generation language is audio command. When you say anything and your order is followed, your instruction is completed, then that is called fifth generation language. So fifth generation language will be the base of artificial intelligence, will be the base of Internet of Things. GUI. CUI is the place where mouse does not work. In the CUI, also called CLI, command line interface, character user interface, here you do all the work with the help of keyboard. Here mouse do not work. You have to make everything by giving keyboard commands. You can't do any click, you can't do any drag and drop which you get in GUI. This Microsoft Word is the example of GUI. Here, especially in the GUI, you get icons, menu, mouse pointer, and many kind of other GUI components. So basically, if you want to make a GUI application in third generation language like C or Java, you will need thousands of line of commands. Whereas if you want to make it GUI application in fourth generation language like Visual Basic, only it will hardly take few clicks, it will hardly take 5 minutes, and you will be able to make any GUI application. So these are the major difference between CUI and GUI. Now talk about software. Software a set of program that governs the functioning of computer. Software has two kinds, system software and application software. System software controls the internal computer operation. It has two parts, system management program and developing software. Now we understand about system management programs. First is operating system. Operating system operates the whole device. It's like a principal. Principal is the mediator between teachers and the guardians. In the same way, operating system is the mediator between user and the hardware devices. Now talk about device driver. Any device you connect with your CPU, that device needs some driver software. Without you install driver in your PC, you can't operate the device very properly. Now talk about system utilities. System utilities are very important softwares like antivirus, disk defragment and all. These are very important. So this is also called system programs. In one line, we understand that system software are very important software. Without it, our device can't start. Developing software. So programming language, we all know about it. It develops programs and softwares. Language translator. Now this is very broad term. Language translator translates a programming language into machine language. As computer understands only machine language, so all the programming language needs to be converted into machine language, and those are converted by translator like compiler and interpreter. Now linker and loader. Linker and loader are used in the process of execution of file. Here we understand it by a picture. You can see here, this is file, source code is file. It goes to compiler, compiler makes object code, and object code is taken by linker. Linker makes it executable file, and loader takes executable file and puts into memory. So linker and loader are the middle steps between compiler and memory. These are linked in the process of execution of a file. Now talk about custom software. Before that, we talk about application software. Application software carries out necessary operations for a specified applications of function. So application software are basically divided into general purpose software and a specific purpose software. But here we talk about custom software also. Now general purpose software, these are the jack for all kind of software, because the word processor, presentation, spreadsheet, image editor, these are that kind of software which are useful for almost everyone. So in fact 90% of the PCs devices have the general software in their PC. So that's why they are called general purpose software. Almost all the computers have these kind of softwares, whether they need it or do not need it. Now we talk about specific purpose software. These kind of software are a little special software. They are not in everyone's computer. They are special software. These are tailor-made. These are bespoke software. Bespoke means they are made on order. So reservation system, we know that tickets are booked by some kind of reservation software which you get on railway platforms, and that software you don't get everywhere. Now attendance system also, this is a special kind of tailor-made softwares. Billing system, many medical shops have some billing system. In fact, many shops have some kind of billing system in their PCs, or report card generator, etc. Most of the schools have school software for report making and all. Now talk about custom software. Custom software is also a major part of the specific purpose software. So this is a software which is specially made for organization as per their requirement. So now we talk about like attendance system, security code system. So custom software are very largely it matches with special purpose software, specific purpose software. So they are almost interchangeable, specific purpose software and custom software. Custom software is also known as bespoke software, tailor-made software.
Type any number, letter or word, it is represented in a certain number system. In our daily life, we use decimal number system, whereas in computers, all the 4 number system, example binary, octal, hexadecimal and decimal number systems are used. Here in this slide, we talk about types of number system. The first one is decimal number system. It has base 10 and digits being used in it is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now we proceed to binary number system. It has base 2 and 0 and 1 is used. Now 2, 3, 4, 5, 6, 7, 8 and 9 cannot be used in binary number system. Now octal number system, it has base 8, 0, 1, 2, 3, 4, 5, 6 and 7. Only these digits can be used in octal number system. We cannot use 8 and 9 in octal number system. Now we proceed to hexadecimal number system. It has base 16 and following digits can be used in hexadecimal number system. Those are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Then A for 10, B for 11, C for 12, D for 13, E for 14 and F for 15. Now here in this slide we will learn how to convert from binary to decimal number system. For example, there is a binary number has been given, that is 110. Now we will see how to convert it into decimal number. Now any number is there, the unit starts from the rightmost. So in the binary number also the unit starts from the rightmost side. So here see in the first line the rightmost digit is 0, then the middle digit is 1 and the leftmost is 1. Now see in the second line, all the number system have certain place value. Binary number system has 2 power 0, which starts from 2 power 0 from unit place. Hexadecimal number system it starts from 16 power 0 from unit place, and decimal number system 10 power 0 starts from unit place. So in the second line we see 2 power 0 is the unit place value. Now see in the middle it is 2 power 1. Now see in the leftmost side it is 2 power 2 square. Now you will notice one thing, that the power is increasing +1 each time when we proceed towards left. Now one thing I would like to add it here, that second line is the exponential form. The place value exponential form is second line. Now the third line is the simplification of the exponential form. Now you can see 2 power 0 turns into 1. Any number which has power 0 turns into 1. Now see towards left, 2 power 1 turns into 2, 2 power 2 turns into 4. Now you see 4 line here. 4 line you have to put little more effort here, that fourth line is the equivalent of multiplication of third line and first line. The third line and first line is getting multiplied and making 4 line. You can see from the right side, 0 into 1 bringing 0. Now see in the middle, 1 into 2 bringing 2. Now see the leftmost side, the top one is getting multiplied into 4 and bringing 4. Now in the last we add the fourth line, 4 plus 2 plus 0. Now total we get 6. 6 is the decimal equivalent of the binary